right, so let's look what we've done so far and then on to routing. So here's our topology. We've done the DLS1, DLS2, ALS1 stuff. And then we're going to go up through and do the routers. And then we'll do DHCP and NAT and SNMP and stuff like that. Let's go back to our list here. All right, so then we did end up configuring the routing. This is just all information about the routing and the port security. Now we're on to routers. Configure IPv4 routing on each router with the correct routing protocols according to the diagram. Configure appropriate interfaces, redistributions, all kinds of good stuff here. So according to the diagram, we have OSPF, BGP, and EIGRP running. On R1 and R3, we have OSPF. On R3, we also have EIGRP. R1 and R3 also has BGP. And then and then R2 only has BGP. So how about if we start with R1? R1 and R3's OSPF. And then when we're over in R3, we'll do the EIGRP for this section here. And then we'll go back and do the BGP stuff. It's actually not that hard. BGP could be super complex, and I could have went really, we could have done all kinds of things with it, but like I said, I'm just going with just the basic instructions, running all the protocols, getting connectivity. And then, time permits, you can always do other stuff with it. So, okay, routers and routing. Okay, sorry, ignore this for a second. All right, I'm going to bring R1's console over. All right, so R1, like I said, I've configured all the interfaces with IP addresses already. Let me just double check. First, let's give my diagram out here. Enable show IP int brief. So I should have a loopback, a gig interface, and a serial interface that are up and have an address. Oh, gig is 1.9. Our serial 0 is 10.1.1, which makes sense because it's connected to R2. And then our loopback is 10.10.1.25. So, ready? Not even close. I must have been like a whole thing off. All right, config T, router, OSPF 1, network 10.10.1.8. That's the link between R1 and DLS1. And that is in area 0. And then our loopback, also in area 0. 10.10.1.24. It's network. So OSPF's done for at least that part. All I had to do is advertise those two networks. Those are the only two things in OSPF. So if I'll go grab R2, not R2, sorry, R3. We're going to do R3 first. So pull that over. Router OSPF 1. Network 10.10.1.12. 0003, area 0. Network, and it has a loopback as well. 10.10.1.32 is it the loopback network? I should have waited. I know it's coming, so no, I don't wait. 00.3, area 0. I think that's it for area 0 on for OSPF on R2. So then our next thing is going to have to be, I'm sorry, on R3. So then our next thing is going to have to be, we'll do our EIGRP. I think that said use named EIGRP, so we'll use named EIGRP with our address family. So exit router. We're going to do the EIGRP for this section right here. And now I just lost my... Our EIGRP name, what did I, CNIT 444. The address family we're using is IP4. When they talk about address families, they're just talking about the family of IP, so IPv4 or IPv6. An autonomous system number, according to the picture, is 20. So it's address family IPv4 unicast autonomous system 20. And then we have to do the networks in here. Network The networks that are in EIGRP are 10.10.1.16.3. Wow, that wasn't it. That is it. That is the right one. And that one is what I configured to be the loopback. That's in EIGRP. And then the other one is network 10.10.1.128. 0.0.127. I think that was another one I had you subnet. I had to have, I don't have the instructions right in front of me. Unfortunately, it had to have like 123 usable hosts or something like that. So then that's how we end up with a 10.10.1.128. As long as it doesn't overlap the other point-to-point networks that we used, we're good. And so now the EIGRP part of it is done. I don't know, I hesitate because if you go, you have the routing, and then it says appropriate interfaces, and then redistribute on R3. And so I think I'm just going to do all the routing, even though it feels like I'm bouncing around a lot, and then go back through maybe. Or maybe we get EIGRP and OSPF to work. Let's go ahead and we'll do our BGP. Let's just get that done with. So BGP isn't as difficult as it seems. It just kind of sometimes seems like it. And I said you need to configure multi-protocol BGP. So since we're on R3, let's go ahead and configure it on R3. Now I'm going to move away, of course, because I want to show you the picture. Oh, BGP. Let's get rid of all our ink. BGP is running on R3 here, right? And then R1 and R2 there. And there, what is it? It's Autonomous System 65512 down here and 65525 up here. So let's go back to our so back to router 3. Let's get out of EIGRP configuration. Router BGP. Autonomous system number of 65512. Because I had to use multi-protocol BGP, meaning I can use IPv4 and IPv6 under the same one, we've got to go. Actually, first let's announce the neighbor. So the neighbor is what you're directly connected to. The neighbor in this instance is 10.10.1.5. That's the directly connected serial interface on R2. And he is in remote autonomous system 65525. Uh-oh, what did I do there? Oh, I know what I did. I think I messed up my IP addressing, if I remember correctly. I think I have 5 on both sides. So I think I tested it and then forgot to change it. Or I realized I didn't forget. So I have 5 here and 5 here, so I've just got to change this serial. So I configured by accident, and then I forgot to fix it when I pasted in my default IPs for you. 10.10.1.5 up here on this serial, and I did 10.10.1.5 down here on this serial, so let's just go ahead and fix that. That's serial 001. S0/0/1. 10.10.1.6. There we go. Now it should work well. Router BGP. At least you get to see BGP twice. Neighbor 10.10.1.5. Remote AS is 65525. Now we've got to actually put that neighbor in the address family and activate it for the address family. So address family IPv4. Neighbor 10.10.1.5. Activate. So we're good. Now, here's where it might have gotten a little tricky, because I didn't really tell you. You could have done it a lot of ways. You could have done default routes. You could have done a subset of routes. You could have done specifically all of your network statements. We have a lot of networks on the inside, right? A lot of 10 networks. If I want router 2, if I don't use default routes, right, and propagate those throughout, which is maybe the way I would normally do it, right? Except for that I am multi-homed in this little network. So maybe I wouldn't want to use default routes. You could use floating default routes. Then anyway, if I wasn't using that, then I would want to advertise my networks so that R2 could learn about it, so that when I go to R2, so say I'm sitting on ALS1 and I want to ping the loopback on R2, ALS1 may know how to get to R2, but R2 can't get back to ALS1, so I need to advertise my networks. I don't want to advertise all those networks. I want to advertise a subset of networks, which works really well. You've seen me do it with EIGRP. Just do, with EIGRP, if I want to advertise, or have all the interfaces participate in EIGRP, I can do a quad zero network statement, right? A quad zero network statement in BGP, the only thing it does is propagate a default route, and only if you've configured that default route. Because one of the rules of BGP is that the route has to be in the routing table before it'll propagate it. So what I want to do is, instead of advertising to my neighbors 10.10.10.0 network and 10.10.20 and 10.10.30 and 10.10.1.12 and 10.10.1.32 and so on, I want to advertise all of them in one overall network. BGP behaves a little differently in this. I can go ahead and advertise that network, so that's what I'm going to do, right? Network 10.10.0.0 with a mask of 255.255.0.0. It says go ahead and let everyone else know about the 10.10.0 network. Here's the thing, and I can go ahead and hit enter. Here's the thing that's tricky about BGP, because what it's going to do is, instead of saying advertise everything that starts with this, okay, so all of my 10.10.10, 10.10.20, and so on, it looks specifically for that route in the routing table. It says, do you have a route to 10.10 in the routing table? And I don't, right? I have a route to 10.10.10, I have a route to 10.10.20, I have a route to 10.10.1, and so on, but I don't have a route to 10.10. Let's go ahead and make one, okay? And we can do that just by creating a static route to null 0. So if I just exit out, and do IP route 10.10, if I should, it's okay, that 0.0, 255.255.0.0 to null 0. Now here's the cool thing. Now BGP will see a 10.10 network in the routing table. It's not going anywhere, but it advertises a subset of everything 10.10, which means that upstream, router 2 will be able to get to everything in my network that starts with 10.10. It doesn't have to be exactly 10.10. Just has to start with 10.10. So that was the easier way. These two statements were the easier way to advertise the many number of 10 networks that I have inside of my autonomous system. All right. That was a long explanation, I know, but I think that might have been, if there was something tricky, that might have been the thing that was tricky. And we should be good there. So let's go ahead and let's do, did I say I was going to do R3? I can't remember if I was going to do R3. I was just on R3. I can't remember if I had a reason I was going to do them in order. So let's go ahead and do R2, or router 2. And router 2 is an autonomous 6525, so he's our external autonomous system. Config T. And it is only running BGP. Router BGP 65525. Neighbor 10.10.1.1. So I've got the neighbor pointing towards R1, or the neighbor that is R1, in autonomous 65512. And then I've got the neighbor that is R3, which is 10.10.1.6. Remember, I had to change that address. Remote AS 6551. Those are my two neighbors. Now I've got to activate. I'll go through and activate my neighbors and announce my networks on R2. .6. And then the networks we want anytime you go through a router in BGP, and you want another router to learn about it or the routing process to learn about it, you've got to advertise it. So even though BGP R2 and R1 are directly connected, so R1's automatically going to know about its own network of 10.10.1.0, R3 won't know about that network because it's not connected to that network via BGP unless I tell it about it. So I have to tell it about that network. So I actually am going to advertise all the networks. So network 10.10.1.0 with a mask of 255.255.255.252. Network. Same thing with the other side of the serial between R2 and R3. If R1 wants to know about that link, we have to advertise it. 10.10.1.4. The 30-bit subnet mask. And then also we want to advertise our loopbacks. And 40 and then 44 is the other loopback network. The other thing I want to do is by default, BGP will only put one path in its routing table. But if I sit in R2, I have a couple different ways, and I don't know if you'd always have this quite like this, of course, because you just got this little network, a bunch of kind of little weird redundancies and whatnot. But R2 actually has two ways to get to multiple networks inside of our autonomous system. So I'm actually going to configure a maximum paths of 2 so that it'll put 2 routes in the routing table by default. And that's it. That's all you had to do with BGP and R2. So let's go to R1 then. Nope, that's R3. Down R1. Let me bring R1 over. And configure our BGP in R1. Did I do R1 already? No, I don't remember. I did not. Okay, good. Sometimes you get going with all these devices. I don't know which one I did. I think I do. I don't. So we want to do config T. Router BGP, the autonomous system is 65512. The neighbor, R1 to R2, right? Your neighbor is whatever you're directly connected to. So my neighbor is 10.10.1.2. Remote AS 65525. And then address family IPv4. Neighbor 10.10.1.2. Not necessarily have to activate them in all of them, so we'll go ahead and do that. And then we got to advertise our networks. And again, we're going to do the same thing on this side. We're going to do the 1010 network on this side as well. So we'll do network 10.10.0.0. Whoop. And then the mask, the 16-bit mask. We've got to create our default route, right? A route of 10.10. 10. Think for a second. 0, 0. Got to have a network, right? BGP needs to have that network in the routing table before it's going to propagate it, even if there are networks that are within that subset that I can get to and that are in its routing table. So we're going to create the network by doing a static route to null. Now our BGP should be done. So we configure the routing. Since we're on R1, let's do the one that says redistribute iBGP into OSPF on R1. So router OSPF1. Redistribute BGP 65512 subnets. Because remember, everything's subnets. We want to make sure everything gets in there. So we've done that bullet point. Should we go through? let's go back to our picture for a minute here. So we've configured our BGP up through here. We've configured our BGP down here in our AS65512. Let's go down and see what we got left. So configure the routing. Redistribute IBGP into OSPF. Configure named DIGRP. Configured multi-protocol BGP. I want to change this. Let's go to pen. So done. Oh, I like red better though. Done. Let's redistribute on R3, because then all our routing should be done, and we should have some connectivity happening here, hopefully. So R3, I want to just redistribute my EIGRP. Oh, let's go R3. All right, R3. Let's redistribute our EIGRP into the OSPF area. Wow, gotta go into the process first. OSPF 1, redistribute EIGRP, the autonomous system number, and again, subnets. I could provide a seed metric. I don't have to when I'm redistributing into OSPF. If I was redistributing the other way into EIGRP, then I would have to. I'd have to provide a seed metric. Otherwise, it counts to infinity or is considered a failed network. Won't be able to get to it. I think that's all the I could redistribute BGP again. I don't really need to, and it wasn't really in the instructions, so I think I'm not going to. So we configured redistribution on R3. Configure appropriate interfaces so they don't send routing updates. I am just going to do this on a couple of them. I think I'm going to do it over in R1 because that's our next bullet point after this is to configure NAT. I'm going to do it on a couple one as an example, but basically anything that's not connected to a router. So on DLS1, it would be Fast Ethernet 06. It would be the loopback, so all the loopbacks don't need it. Fast Ethernet going to the server or Fast Ethernet going to the PC, either of the PCs would be passive. What would not be passive, none of your serial links, obviously none of your trunk links, none of your VLAN interfaces, none of the links between R1 and the distribution or DLS1 switch and R3 or the DLS2 switch. We wouldn't do that there either. Would not want to do that. Oh, so what am I gonna, let's make a loopback passive into OSPF. So we're in R1, router OSPF 1, passive interface loopback 0. That's literally all you got to do. So I'm in router 1. The only interface in router 1 that should be passive is the loopback. I could do a passive interface default, which would make all of them passive. And then you'd need to do a no passive interface S0/0/0 and no passive interface GI0/1. So you just go through and do that under OSPF. So in DLS1 under OSPF, you go router OSPF 1, then passive interface FA06 for the one that's connected to the server, and then passive interface loopback 0 for the loopback, and just kind of make your way all the way through the routing domain or all the way through in all the devices. So that's how you'd create a passive interface. Now it says configure dynamic NAT on R1 for host going to R2 loopback. We're just going to say R2 because I want to go to the out. I specified loopback because I want to make sure I could get through R2, but in reference to where we're at, it doesn't. We just want to get to R2. It's like sort of like our internet. And configure static NAT on R1 for SRv1 communication with R2. All right. All right, so we did all of our connectivity things. We got our routing done, our passive interface, our redistribution, all that good stuff. BGP's running. Now it says configure dynamic NAT on R1 for the host going to R2. Configure static NAT on R1 for the server communication with R2. It says loopback. R2 is fine. I just want to get through R2. I want to make sure we have connectivity through R2. So when we're going up, we're NATing, we can get all the way through R2. Um, so one of the things we have to do the dynamic NAT, we can do some sort of overload, but we're going to do a pool, and BGP needs to know about the network that we're translating to. So here's the kind of the cool thing about NAT that I think we forget. We don't necessarily have to translate. Let me see to, I don't have the pen. We don't necessarily have to translate to the address that's on this link. We can translate to any address. So if we're allotted an address, we just have to route it. We have to know about it. And BGP is going to have to know about it if I want to. So if I'm in this little scenario, PCB is going to go up through here. It's going to go through DLS1, through R1. It's going to get natted at R1 to some sort of address that we put in the pool, and it needs to get to R2, where only BGP is running. Then that response needs to come back from R2 down to PCB. In order for BGP to do that, it has to have a network to whatever pool of addresses we decide. And we're going to deal with that the same way we dealt with trying to summarize all of our 1010 networks. We're just going to create a route to null and then advertise that route. So the dynamic pool that I'm going to use is 215. Sorry, I can't draw very good with the mouse. .2. .2.0. So I'm going to translate the addresses here in this network to 215.220, something in that subnet, as they leave my internal network. So as they leave R1 to say go out to the internet, if this was the internet we're simulating, as they leave our network, we're going to translate them to 215.220 something. And so what we're going to have to do is configure NAT, and NAT is fine. NAT will work as it's supposed to, irrespective of the routing that we have happening. The only issue is that when we translate to an address that's not being advertised, that we don't know about, we have to advertise it and make everyone know about it. So let's bring R1 over and work on that. All right, the first thing we want to do is define our interesting traffic. What is it we're going to translate? Let's just translate PCB, not PCB by itself, not the host, but the network that PCB is on. He's on the 10 VLAN, right? I think I messed this once up already. PCB, where? I don't have him. I think he's on the 10 network. Oh, I suppose we should do a show IP in brief on the access since I don't have it written down. Sorry, I don't have this written down. I got to double check before I show VLAN brief. Yeah, so PCB on F18 is on 10. Okay. So we got to define our interesting traffic. What is it we're going to translate? What internal networks are we going to translate? So we do that using an access list. We'll just use a standard one. So access list 1, 10.10.10.0. And then that one's a 24-bit set of mask, right? Yeah. So then the wildcard would be, so if it's 24 bits set of mask, then with access list we use a wildcard. So the wildcard would be 0.0.0.255. It's the inverse of a subnet mask. So that's what I'm going to, oh, I forgot the keyword permit. Access list 1 permit. So that's the network I'm going to translate. When PCB goes through R1 and leaves R1, I want to translate it to a set of addresses. The set of addresses is the pool that I'm going to create. IPNAT pool, and then give it a name. I'm going to call it hosts. And then what's the range in that pool? What addresses are going to be translated to? I'm going to do 215.2.2.1 all the way to 215.2.2.9. This is a range. It's not an address subnet mask. It's saying you can use all the addresses within the .1 to .9 pool. And the net mask for this pool is 255.255. So we have plenty we can still use. Right now we're just going to use these. We have plenty we can still use. So we have, what is it we're going to translate? What are we going to translate it to? Now we've got to link them together. IPNAT inside source list 1 pool hosts. Link our interesting traffic, so link our access list with the pool that we're going to translate it to. And now we've got to say, okay, what's the inside and what's the outside interface in this classic NAT? A newer NAT, there's a newer NAT, we don't actually have to do that. But in this NAT, we do. And the inside is the inside of my network, right? So my inside on R1 is going to be my gig, and my outside will be my serial interface. We're translating coming this direction. Let's go. I gotta go back and get my window. All right, so int gi 0/1, right? IPNAT inside and int 0000 IPNAT outside. So the first of the two NAT bullet points are done. Then it says configure static NAT R1 for SRv1 communication with R2. We don't have to do inside and outside because you can't do it twice. I mean, it's either an inside interface or an outside interface. We've already created our pool for dynamics. So static is simply saying, take this IP address, translate it to this IP address when you leave. That's just one additional statement to accomplish that next bullet point. IPNAT inside source. Notice it's not a list this time. Static 10.10.40.10, that's our server address. And I'm going to translate it to 215.2.2.10. That's an address outside of my pool. So I went one up from my pool because these are all be used for my pool. This one won't be pulled from the pool. The actual NAT configuration is done. NAT by itself, like irrespective of routing or connectivity, NAT will work. The problem is no one else knows about this 215 network. Specifically BGP, what we're trying to translate to, doesn't know about this network, right? So we've got to go ahead and advertise the network in BGP, but that route has to exist in the routing table. So the first thing we want to do is do another route to null. So IP route 215.2.2.0, and then our subnet mask 255.0, and we want it to go to the bit bucket, so we want it to go to interface null 0. That's basically what null, it's just a null 0 interface, or a bit bucket, or whatever you want to call it, because it's going to route to nowhere. We don't want it to do anything. We just want it to be in the table so that BGP will propagate it, so that when it gets that NATed address, that when our PC goes through R1, it knows how to return it. You know, it's like, okay, I got this 215 address. Well, where does it go to? Now I can go ahead. I'm in R1. R1 will then advertise out that it owns the 215.2.2.0 network. So now I'm going to go into BGP. 655.1.2. The IPv4 address family, network 215.2.2.0. Now we have networking and connectivity. Unfortunately, we can't verify yet because I don't have a PC in the 10 VLAN right now. If I do show IPNAT translations, we'll see our static one right away, you know. But we haven't dynamically translated anything yet. But we did cover those two bullet points. All right, now it says configure serial link with PPP encapsulation and CHAP authentication. Okay. So let's go just through and do that. CHAP authentication requires username and password. Passwords have to match. Usernames need to be the name of the router. So I'm sitting on R1. It needs to be username, the router you're connected to. So I'm connected to R2. So username R2. Password, we're just going to use the word test. And then we've got to go into the serial interfaces, int S0/0/0. Encapsulation, PPP, so that's our PPP encapsulation. And then PPP authentication, CHAP. It's going to start going down because right on one side of the link right now we're running PPP. On the other side of the serial link we're running HDLC, which is the default. So we'll have to fix that. Let's go into R2. So I'm bringing my R2 window over. R2 has two neighbors. So username R1. BGP starting to go down. We're having an issue, right? Because our interfaces are going down. Username R1. Password test. And then we've got R3 as well. Username R3. Password test. And then we go into the interface. So int s0/0/0 is the one facing R1. Encapsulation PPP. I might need a C there. I can't remember. Then PPP PPP. PPP authentication chat. And then the serial interface facing R3 is 00001. Encapsulation PPP. Just hit the up arrow. It did it, but. And then PPP authentication chat. Okay, so R2 is done. Let's go into R3 now. And that's 00001. Shoot, let's use our username first. And again, we're losing our adjacencies, which totally, with BGP, which totally makes sense because we're running, PPP on one side, HDLC on the other side. Username R2, password test, int s0/0/1 to go to the serial interface, encapsulation PPP, give it a second, because inevitably I'll type in it, and then I'll have to type it again anyway. And PPP authentication chat. Now everything should come up. Looks like we did. BGP will activate again. We'll get our sessions up again. So now it looks like we're done with the router stuff. Next we have services and network management. I'm thinking maybe that's a part 3. These are getting pretty long. I suppose